detect what the other nulls for the country column are. Tukolo, I missed you, right? You can answer this question. Can you guys hear me?
Yes.
Yes.
Tukolo. Is Miriam here?
No, she's not.
I
Not
can
Tukolo?
try.
Okay.
I'm not sure.
Mm.
This is just from reading that I did earlier on today. Would you use fill in A or not?
You're on the right track, but specifically for, yeah, that would be one of the ways. Let me put it like that. So, yeah, you're not wrong.
Okay. So
But then, yeah.
So, I don't know. I know the sentence, but I don't know how to write that in Python.
Yeah, if only you could like speak something into a mic and then it puts it down as code.
I'm telling you, that should be the next innovation.
Okay. So you could use fill NA. So it's good that you know about fill NA, which is fill nulls. From my previous experience, I've used that with numerical data. I'm not sure if you can do it with categorical data, like by saying fill NA based on whichever country appears the most.
Wouldn't you then use like a subset? So wouldn't you say like drop NA, then you have like a subset, and then you would then you would add the columns in quotation marks and brackets, and then how would be equal to maybe any or like all or shape, something along those lines.
Yeah, so that when you talk about subsets, now you're getting somewhere. So as a data set, as a data scientist, you'll know that sometimes you don't have to use all of the data. So you'll be able to tell, okay, they told us above that there's only 25% nulls. And then if you want to see, let's see how big this data set is, which is one of the first things we should have done. So that's df.shape. It tells you the shape of the data set. So because we only have 266 rows, so these are rows, these are columns. Let me write shape and I'll put at the top shape of the data set. We only have 266 examples, rows. So it may not be a good idea to just choose a subset. But I know that you are mentioning subset with regards to imputing. Yeah, that's something I'd have to do research on with regards to fill NA for categorical, meaning for data that's not numerical. So fill NA I usually use for numerical data. So the way that, that's good that you knew all of that. So on the right track, and also your thinking is on the right track. The way that we're going to do it is because our data set gives us the latitude and longitude, which is the location coordinates, we can use that. All right. So if you have the latitude and longitude of a place, you can use Google as a package, and it'll tell you, all right, for these location coordinates, the town is this or the country is this. Right. So always go through your data set, make sure you understand all the columns that are there and what each column can tell you, what information can you get from there. So latitude and longitude, we can get the countries. Okay. So here we're just seeing in the column latitude, longitude. Let's see what's in it. So you say dot head. So when you want to access a column and a data set, you can say df dot latitude, longitude, which is the column name, or be on the safe side, you can also do it like this. df square bracket. So saying in this data frame, take the latitude, longitude column, and you can also say dot head. Let's run it the first way. It's like that. Let's run it the second way. Same thing. Okay, so that's the latitude, that's the longitude. Fine. Now we'll notice that the latitude and the longitude are concatenated, meaning they are joined in one column. We have the latitude and the longitude in one column. This may be a problem because when we query on for Google, it may require us to separate. This is the latitude, this is the longitude. So we're gonna start off by splitting the column into two columns. So we're gonna use Ezra's favorite function, which is dot split. And I'm going to split it into two columns, one for latitude and the other for longitude. And you'll notice that. So when you want to do splits, not the physical splits like yoga, no. When you want to split something in your column, you have to see what's the separating delimiter. So here it's a comma. It could have been a semicolon. It could have been a dash. That's going to matter when we do our splitting because this is where we want to split. We want to split, yeah, where there's a comma, then you have your left value, your right value. Okay, if you want to read more about split, you go to Pandas, that link right there. So what we're going to do is, okay, we want to create new columns, right? So we're creating new columns, which is df latitude, df longitude. When you create new columns, you always specify, not always, because we're using two columns, you're going to put double square brackets. Double square brackets, because for two or more columns, for assigning values to two or more columns. Okay, then we're going to say df dot, which is now in our data frame, dot tell us which column we're using. We're using latitude and longitude. Dot str, so you're saying take this column as a string because you can only use dot split on a string. Str dot, and the function is split. And then remember the delimiter is a comma because our values are separated by commas. If you made a mistake and put a dot there, it was going to separate by these right here. Expand equals true. Not sure what that means, but it can run without it. So whenever you're not sure what a parameter means, use Shift Tab, and then you press here, show the current doc string, and it'll make it bigger. And we scroll down, here's parameters. You want to see what the expand parameter means. So expand is a Boolean. The default value is false. Expand the splitted strings into separate columns. If true, return data frame. Expanding dimensionality. If false, it will return a series containing lists of strings. There we go. So we want it to be true because we don't want lists of strings. Okay, and then we're going to delete df lat long. I don't think this is good practice. So what you'd rather do is df dot drop, like I showed you, where you're dropping a column. This is how you'll do it most of the time. You have drop lat long and axes. Does anyone remember the axes? If you want to drop a column,
It's 1.
yeah. x is equals 1. And what do we put when we want our function, what we're doing, the dropping to be permanent and not temporary? Tukulo? Is Tukulo here, guys? Ezra?
Yes.
What do we do when we want the column that we're dropping to be dropped out permanently? Let me give you a clue.
No, I don't know.
Yeah, so in place.
This,
Yeah, you know the answer of that, right?
In place true.
Yeah, there you go. So I want us to first run the first one. So we're creating a new columns called latitude and longitude. And then let's do df.head so that we can see that these columns were in fact created. They're going to be created. There we go. Latitude, longitude. So it took the left and made it latitude because we specified lat first here at the top, and then took the right one to be longitude. But as you can see, lat long is still there. We don't need it anymore because we've got the data that we need. So we're going to do the df.drop lat long x is equals 1 for column in place equals true so that it's permanent. If we don't put in place equals true, it'll just show you a snapshot of your data set. Oh, sorry, instead of making it permanent. So next time you run it again, it's going to be the same thing. So put in place equals 2 to make it permanent. Then you can do, yes?
So that's permanent if you're deleting from that from the sheet or the data frame that you're using. But what if you're deleting and deleting, but then as you're deleting, you're creating a new data set. Is that still going to be temporarily?
No. So if you want to create a new data set from what you deleted, because you want to keep the old data set that has that lat long, so let's just call it df2 equals. Then when you do it this way, because you're assigning your data frame to a new variable, it'll be permanent because you're assigning. So this in place equals true. You don't need it there. Like, let's try to run it. You'll get an error. Oh, we already removed it. My goodness gracious. But then, yeah, if you're doing it that way, like creating a new table, you don't need to put in place equals true. You actually get an error.
All right.
Yeah.
Thank you.
Okay. Let me remove cell output clear. Okay. So now when you do df.head, you can see I went to the end. Lat long is no longer there. Okay. Now we're going to get the country name. We're going to get the country name from the latitude and longitude. How are we going to do it? So as you've noticed, we import libraries and packages like into Python. I think I've mentioned before library and package. It's just a collection of functions that someone else wrote to make your life easier. So then, okay, you don't really need to know that. Modules, packages, they literally, you can use them interchangeably as well. You wouldn't need to know this theory, just know that you have packages and you import, and it's a bunch of functions that someone else wrote to make your life easy. For more information about Python libraries, modules, packages, you can visit this link. So we are going to use a package called that Google created. Well, Google is the man. Google is the bomb.com. Where are we? Where is it? Where is it? We're going to use, it's called Geocoder. It's a Python interface for Google Geocoding API. Geocoding is attacking when you have location data, geo for geography, in your code, and you want to do something with it. So Google Geocoding API. An API is like it's like a tool that other people create that helps you get information where you want it to be. So you're going to use that tool to get information from Google. And then that information is going to come onto Pandas. So we're going to use that API. It's a tool that they've created. So you can use it to geocode, meaning you give a name to latitude, longitude. You can reverse geocode. So you can either have latitude, longitude and get the name or the street address, or you can have names or street addresses, and then you can use the Google API to get the latitude and longitude. So you could do it reverse. And you can use it to validate or create addresses. You don't have to know this package from the top of your head. The trick is learning how to use Google and Stack Overflow. Like I said before, that's your friend. And then if necessary, the solution requires using a modular package that you may not understand well. So sometimes when you're importing packages or libraries, you may not understand. So it's good to read through documentations. So you can even go to Google and say, Google Geocoding API documentation, and you get a documentation. Pandas documentation, you get documentation telling you how it works, which parameters you use, how to install it, and such. So you can do that for anything. Okay, so pip. Does anyone know what pip is? Or conda? Ezra, you don't know?
Yes, I use it in Linux to install something who has Python in it. Perhaps it's not good, but I use in Ubuntu to install something.
Yeah, I also use it in Ubuntu. Yeah, so pip enables you to install packages.